Ready to start on these notes. We're at 8.3, proving triangle similarity by side, side, side. And, oh, I have a typo. It should be triangles similar and similarity. That should be a plural. Okay, as you know, I always start by putting my name on here. If you want to follow along in the book, this is page 435. Okay, so my objective for you is very simple. It's just to be able to use these two theorems. So students will be able to prove two triangles are similar by either the side-side-side similarity or the side angle side similarity. So like I said, the beautiful thing is you actually have already gone over these in a previous chapter, so we're not going to spend a lot of time going over them again, but we will review this. Okay, if you can also use corresponding side lengths, which we'll have an example, and it'll make your problems even easier to solve. Let me lock that. Okay, so our side-side-side similarity theorem is going to be abbreviated like that. We're just using the squiggly, and here's how it goes. If the corresponding side lengths of two triangles are proportional, then the triangles are similar. So this is where I'm going to be using my colors. What it's saying is, if you compare AB to RS, and you compare AC to RT. Remember, if you do AB, it has to start again with AC on the top. They all have to be on the top. And last, it will equal the proportions BC over ST. If these all equal the same thing, okay, the same number, then you have that triangle ABC is similar to triangle ABC RST. Remember, it has to be the same direction. There we go. And that's what you need. So you need to be able to get the ratios of the sides equal to the same. So we'll do an example right here. Is either DEF or GHJ similar to ABC? So this is the first one, and we're going to compare it to each of those. So let's do our colors again. So we're basically going to figure out if these are equal. I'll start with red. All right. So is AB over, let's see, so this one, we have to figure out which one is corresponding. First of all, I'd have to flip it upside down, right? So it would look like this. And then second of all, see how 8 is shorter than 12? Well, this one is 6, so it's shorter than 9. So really the one that this corresponds to is this here. So I need to see if these correspond, and then this would correspond to this one, the other slanted one. So that's BC over EF correspond, and I need to see if that also corresponds. So then AC would correspond to FD. And so I'll just plug those numbers in and see what happens. So AB is 8, DE is 6, BC is 12, EF is 9, AC is 16, and DF is 12. So this reduces to 4 over 3. This reduces by 3 to 4 over 3, and this reduces to 4 over 3. So yes, triangle ABC is similar to triangle DEF. That's all you need to do is get those three similarities. Now, I'm going to do this one compared to this one. So this looks like it's flipped this way, which means my short side over here is going to correspond to HG. Okay, and I already see a problem. Does anybody see a problem here? Even before we start writing down numbers? I want these numbers to all come to the same. So, let's see. So, the red over the red is 8 over 8. The blue over the blue is 12 over 10. And the green over the green is 16 over 16. So these are equal. This is 1 and this is 1. But this is 1.2. So that means that these are not similar. Okay, that means that this is the only answer that is, correct on that. Any questions? You can ask questions. Let me zoom in just a little bit, make this a little bigger. Okay, so now that's how you compare them. Just do the sides and the ones that are corresponding. So let's say you've got a marked here and you have x's. Well, you can solve for x if you know other sides. So this proportionality statement we can write is, I'm going to color it again because this will make it more helpful for me to see. So my ratio is 4 to 12. Okay, and 4 to 12 will equal x minus 1 over 18. Or, if you wanted to solve it a different way, it would equal 8 over 3 times x plus 1. So there's a number of different ways you could write this. Okay, so 4 over 12. 4 over 12 equals x minus 1 over 18. But it also equals 8 over 3 times x plus 1. So you can write that down, that's what would make it similar. However, this is where I come in with my however. So, like I can write this equals that or this equals that. But if I write this equals this, then I end up with x squareds. So I don't want to do that. So I'm going to use the easier one. I'm just saying you can do it different ways. But this one to me seems easiest because it's just x minus 1. So I can reduce these both by 4. You get 1/3. So 1 over 3 equals x minus 1 over 18. I can do my cross products. And then I divide both sides by 3. I'm going to add 1 to both sides. So x is 7. And that's a reasonable number. That would make this 4, this 6, and this 8. 12, 18, yeah, that works. And I would just bet you $100 that if you use this in the proportion, you get the same answer for x. So I always just go for the easier one. So see, you already know how to use side, side, side. We're now going to do side, angle, side, okay, which again, the abbreviation is SAS with a squiggle, also known as tilde. If one angle of one triangle is congruent to an angle of a second triangle, so here we've got this, x is congruent to m, and the length of the sides, including these angles, are proportional, then the triangles are similar. So really what you need is you have to have xz being proportional with mp, and you have to have xy being proportional with mn. Okay, so x, y, and n has to be proportional with x, z, P. So you have to have angle X congruent to angle M, and you have to have this proportion. But if you have those two things equal, then you can say that triangle XYZ is similar, XYZ is similar to MNP. That's what that theorem says. So again, remember, it has to be the two sides that include that angle. It can't be the opposite side. Any questions before I turn it over? We're going to do some problems that are real life problems. Okay. And again, if you want to see other examples, watch the other video. Here we go. You just got cast on the show Survivor, and you're building a lean-to shelter starting from a tree branch with your tribe as shown. Can you construct the right end so it is similar to the left end using the angle, measure, and lengths shown? So yeah, of course you can. All right, the first thing we're going to do is simply trace our triangles because I can't see it very well in this picture, but I do see, here's FGH, and I see ABC. So perspective looks a little different. And I also notice right here, they're both marked 53 degrees. So I have angle F is congruent to angle A right away. They're both 53 degrees. The other thing I need to check is the two included the two sides that create the included angle. So I'm going to color code again. I'm going to do this one compared to this one. It has to be proportional, and it's going to equal this side compared to this side. Okay? So really what the work that you're going to write is 6/9 equals 10/15. And if they both reduce to the same number, okay, then side angle side tells you they are similar. So I'm going to reduce this one by 2. No, by 3. No, but yeah, by 3. So 6 divided by 3 is 2. And 9 divided by 3 is 3. And this one I'm going to reduce by 5. 10 divided by 5 is 2. And 15 divided by 5 is 3, which is like big check. So because you have all three things, you have a congruent angle, and you have these sides in proportion, then yes, the triangles are similar by the side angle side. Similarity theorem. Again, any questions? That's where I ask for any questions. Does that color coding help you guys? Give me some hands up or some thanks or something like that. Uh-huh. Okay. Thank you. Thank you very much, Andres and Faria. Okay. 2 questions. So now these are like, more like the problems that we would solve in big ideas. Given that DE is parallel to BC, so first thing I'm going to do is I'm going to take my little red marker and mark that they're parallel. Okay, they're parallel, and AD is 2.6, AE is 3.3, BD, which is from here to here, is 3.4, and EC is what we're looking for. So this theorem actually is the side one, but no, you can't use side because these are different angles. So you've got a smaller one, right? And then you've got a bigger one. And the thing you know about these is they both share this angle right here, right? So if you can't see that, what you would want to do is just redraw it. So this bigger side here is x plus 3.3, and this one's 3.3 from here. This one's 2.6, and then this one is 2.6 plus 3.4, which is 6. And then you can write your proportion and solve for x here. That's all you need to do. So let's see, it's going to be, well, since you said it was helpful, it'll be this side over this side. So 2.6 over 6. And that's going to equal 3.3 over 3.3 plus x. So this is going to get a little messy with our decimals. That's okay. We have our handy dandy calculators, and we'll figure it out that way. So this is going to be, this way it's going to be 6 times 3.3. So 19.8 equals, and then we'll multiply 2.6 times 3.3 and see what that gives, 8.58. Plus 2.6 times x. So we're going to subtract 8.58 from both sides, and we're going to get 11.22. And then we're going to divide both sides by 2.6. And it'll give us 4.3. So x equals 4.3. And it's okay to chop it up. We'll just round things to the 10th because all the numbers that we got in the problem were to the 10th. And so there we go, 4.3. There you go. So again, we're going to ask any questions. Then that's a solid problem. And then this one is this triangle similar to this one. Now there's actually 2 different ways you can answer this because, well, you'll look at your markings, right? Well, first of all, you know that this one here is going to be like your A, right? If you put it straight up. You also know that these markings mean isosceles. So let's say I call this side x and this side x, because they're both the same, right? Let's say I call this side y and I call this side y. Well, a couple of things. First of all, I know in an isosceles triangle that if that's 74, then that's also 74. And if those two are 74, then I can figure out if this angle is the same as this one. So 74 times 2 is 148. So if I do 180 minus 148, then I get 32. Ha ha! So that means that right here is 32, because I just figured that out. So if this is 32 and that's 32, that means these are 74. So we have the triangles the same. What we need to know for similarity is if this length, you need to know is AC over the side will be DF is in proportion to AB over DE. That's what you need to know to say they're similar. Okay. Well, if I just plug in x and y, AC is x, DF is y, AB is x, and DE is y. So they're the same. It doesn't matter actually what they are, you just know that they're the same. So yes, they are similar by SAS. However, because you have the same angles, technically, you could also say, like as an aside, they are also similar by AA because we already figured out the angles. So again, this wouldn't be something on your quiz if there's, unless it would be like check all that apply. You know, you can solve both. We're not going to solve any more than that for today. And I'm going to send you over to Big Ideas. We'll do the proofs of these tomorrow so that you'll have, because you'll notice in the notebook that this is a separate sheet of notes, and we'll do those tomorrow so you'll have 20 minutes.